Disclaimer: no one was hurt in the making of this video. All skits performed in this video are purely for entertainment purposes and should not be recreated without adult supervision. Anyways, I hope you enjoy.
So for today's experiment, we're going to be slapping random people to see their reaction. Let's check it out.
Well, that didn't go according to plan.
You know what?
You know, you're right. We can't have these innocent people dying on us mid-sample.
Wait. Why can't we just do something simple and safe? Like a test on rock, paper, scissors?
I mean, just look at this guy. He's absolutely destroyed.
That's a damn terrible idea. Rock, paper, scissors is going to be so incredibly boring. Like, I can just snip that idea in half. You got me? Don't you dare come here.
Alright everybody, welcome to the 282nd annual Rock, Paper, Scissors tournament.
Alright, this is the first round. Contestants, please select your weapons. On the count of shoot, we'll begin. Rock, paper, scissors, shoot. For round two,
Give me this.
rock, paper, scissors, shoot. For the final round, I want to remind everyone that this game is all about being safe. On the count of three, rock, paper, scissors, shoot. And that concludes our tournament.
Whoa. We can't do that. It's a little too much. How about we do something like this?
Scissors, shoot. Okay, warming up. Rock, paper, scissors, shoot.
Alright, so this is our rock, papers, and scissors presentation. Our official null hypothesis is that the proportion of people at Central High on their first choice in the game of rock, papers, and scissors are equal. Our alternative hypothesis is that they are not equal. We plan to do a chi-square goodness of fit test at a significance level of 5%, so we need to satisfy these three conditions of randomness, independence, and shape for normal distribution. For randomness, our sample was technically randomly taken as we sampled random students from different classes and locations at Central High. For independence, since we have a sample size of 51 students, we need 510 students to exist at Central High to satisfy 10% condition, which there are, so we're good. Additionally, the choices of each participant were not dependent on other students. For shape, our smallest distribution group, paper, was more than 5, which is all we need for a chi-square test. As you can see in this pie chart, 9 participants picked paper, 13 picked rock, and 29 picked scissors. We can already see a significant difference from our expected pie chart in which we expect 17 participants to pick each option. Now let's get to our calculations for p-value. We put our expected values in list 1 and observed values in list 2. And our degree of freedom is 2 because we have 3 groups, rock, papers, and scissors, and 3 minus 1 is 2. Chuck that into the calculator and we can see that our test statistic is about 13.176, our p-value is about 0.00137. Additionally, the CNTRB value tells us which group contributed most to this low p-value. The 3.1764 correlates to our paper value. Our rock value is less than 1, which suggests that it wasn't as impactful. However, although you cannot see it here, the paper value was between 8 and 9, which suggests that it contributed most to the slow p-value. Alright, let's conclude now. Since our p-value was less than our significance level at 5%, we reject the null hypothesis. Therefore, there is significant evidence that the proportion of people at Central High on their first choice in the game of rock, papers, and scissors are not equal. So maybe next time when you're trying to win a game of rock, paper, and scissors against Central kids, consider picking rock. Do note that this only works for the first game or interaction because some people might start developing some game theory. There also might be some confounding factors because our experiment was not perfectly designed in terms of randomness, but we believe that since rock, papers, and scissors is a luck-based game, those factors can be negligible. Additionally, we did have some non-responsive people, which we will briefly mention later. We also have some extra stuff or fun facts. We can call it the win, tie, and loss distribution from the perspective of Central students that we sampled. As you can see in the bar chart, the expected values are pretty similar to the observed values we received. When we put our observed and expected values into the calculator, we can see that we get a pretty high p-value. This suggests that the first interaction of rock, paper, and scissors is indeed luck-based on who wins. But this data might be confounding because we didn't design our experiment for this, as our choices of rock, papers, and scissors were somewhat questionable. Also, we have someone like Anthony in our team who has a horrible win rate in this game.
Do you think he's okay? Hey. Bro, no, don't. Henry, what is it? What is this for?
Alright, ready? Go.
No, you have to wait for him to say. Alright.
Recording?
What is this?
Recording.
Richard, wait, don't record yet. Have Richard sit down.
I don't even know what I gotta say.
Okay, if you zoomed in on his face, if you zoomed in on his face, like start nodding, can you see Alvin in the back?
Yeah.
How well? Let me just want to see. Alvin, can you start sliding? Act like you're dead and just start sliding.
Wait, how can I act dead?
Just
Slide underneath the
Just slide
desk.
under the desk. Just keep sliding. Yeah, like that.
Yeah, that was good. Wait, that's real. We're using that. We're using that.
No, but we can't be talking like that. Do it just. Not going to booper.
Alright.
But we'll do it like that. All right.
Wait, what the happened?
Just like that. Okay, so. Did any of you bring your chromebook?
No.
I need script.
Wait,
I'll be right back, guys.
Wait, you guys see what happened in that clip?